Welcome to my channel Adhyan with Flow. So let's start with functions of tubule. In our previous video, we all discuss about how urine form, okay, how urine excrete, what is the GFR, everything. And now let's start with function of tubules like PCT, Henle's loop, TCT, collecting duct. Let's start with PCT, proximal convoluted tubule. Which functions performed by PCT? Absorption, simply. Which function performed by Henle's loop? Absorption. What function performed by DCT? Again, absorption. So PCT, Henle's loop and DCT, these are three tubules. They perform absorption, reabsorption. But PCT absorb different type of ions. Henle's loop absorb different types of ions, and some parts absorb water molecules, some parts of Henle's loop absorb ions, and DCT absorb in different style. They absorb water but in a different way, hormonal way. Let's start with PCT. PCT is lined with simple cuboidal brush border epithelium which increase the surface area of reabsorption. They want to say that PCT has cuboidal brush border epithelium. Brush border, what they do? They increase surface area for absorption. They absorb more and more thing. What they absorb? Essential nutrients like 70 to 80% of electrolytes absorbed by PCT. 70 to 80% water absorbed by PCT. Means if 100% filtrate goes forward, then 80% to 90% absorption done by PCT. PCT also help to maintain the pH and ionic balance of body fluids, selective secretion of hydrogen ions, and they excrete. What they excrete? They excrete hydrogen ion and ammonia. Now let's switch towards Henle's loop. What they do? Reabsorption is minimum in ascending loops. However, this region plays a significant role in maintaining the high osmolarity of medullary interstitial fluid. They want to say that this is a U-shaped structure. We call it as a Henle loop. They divided into two parts: ascending limb and descending. Some part of Henle loops is permeable for water, and some part of Henle's loop is impermeable for water. So due to permeability and impermeability, they maintain osmolarity. Of filtrate. Means if I say high osmolarity, you have to understand that water is less and solute like ions have high. If I say low osmolarity, then you have to understand that water is high and solute less in number. Descending loop of Henle is permeable of water but almost impermeable of electrolytes. They said that descending limb of Henle's loop permeable for water only, for H2O only, and impermeable for ions, isn't it? Now the ascending limb is impermeable of water but allow transport of electrolyte actively. They want to say that ascending portion of Henle's loop, they impermeable for water but permeable for ions actively, either passively, both. Now let's switch towards distal convoluted tubule. What they do? Of course, reabsorption of ions and water. DCT is also capable of reabsorption of bicarbonate. This is the important star mark here. No one can absorb bicarbonate, but they absorb. So we can mention selectively secretion of hydrogen and potassium. They also secrete that Henle's loop and proximal tubules, they all are secrete H plus ion. They secrete H plus ions. Some potassium, some sodium, some hydrogen ions, some ammonia. Okay, they secrete. They maintain pH like PCT and sodium potassium balance in blood. Of course, definitely. Look at here, very beautiful guy, very beautiful. This is the location where which kind of thing is absorbed and which kind of thing is secreted. If inward, this is inward movement. If arrow is towards the tube, it means they show secretion. If arrow sign away the tubules, this one, it means they absorbed. These are absorbed thing and these are for secretion. This sign away the tubules, it means they get absorbed. And this thing, they secrete. This thing absorbed, this thing absorbed, but this thing arrow towards the loop, this is for secretion. This also absorption. Now let's start. Here to here, this complete part is PCT. This complete part, this is convoluted tubule. This complete part is PCT. Come on guys, be attentive. This is PCT part. This is PCT part. And what PCT will do? They absorb bicarbonate, they absorb some ions, NaCl, they absorb water, they absorb nutrients, they absorb potassium ion. Isn't it? Be specific guys, be specific. And what kind of thing they secrete? H plus ions out. Urea out, means ammonia guys, ammonia. Ammonia out. They don't need H plus ion and ammonia. Now this is the loop of Henle. This is the loop of Henle and this is the descending part of the limb. They are permeable. They are permeable for what? Permeable for water and impermeable for ions. So in descending parts, they absorb only water and they can't absorb ions. But in ascending part, they absorb ion, permeable for ions, not H2O. This part absorb H2O, but this part can't absorb H2O. And now, here to here, this is complete structure of DCT. Complete structure of DCT. They absorb some important ions, they absorb water, and they absorb carbonate ion. Sometimes they excrete also. And basically they excrete potassium ion and hydrogen ion. They excrete. And they goes toward this also. They goes toward where? Where to where? Where to where? DCT to collecting duct. Urea also secreted here. And now H2O is still in collecting duct. Urine are collect, but collecting duct also show some absorption power. They absorb water. And now this is the ending part joined with ureters. So that's all it. We have complete our PCT, DCT, loop of Henle, and last is collecting duct. This long duct extends from cortex of kidney to the inner part of the medulla. Large amount of water could be reabsorbed. Be specific. Could be reabsorbed from this region to produce a concentrated urine, not diluted. Concentrated means more solute, less water. If I use diluted means more water, less solute. That's it guys. And secretion of H plus ion and K plus ion. This is all about functions of tubular part. We already study glomerulus and Bowman capsules, how they function, how they both function. They do filtration. Tubular part, they do absorption. And collecting duct, they absorb as well as they excrete. Let's quick review of mechanism of concentration of filtrate, how they balance osmolarity. Let's start with this diagram. You can understand all the thing. I'll explain here. Come guys, come with me. This is the glomerulus part. And this is the cup-like structure is Bowman's capsule. Clear guys? Clear? This is the glomerulus part. What they do? Function of glomerulus is filtration. Bowman's capsule, cup-like structure. What they do? They do what? Filtration. Alright. Now let's move forward. Here they show what they show. Osmolarity. They're showing osmolarity, that filters osmolarity is 300. It means I show 300 means less osmolarity. Means water high and solute less. That's why this is the reason that water high, and how can they remove without our permission? That's why PCT absorb water. After absorbing water, now osmolarity is this, means now medium osmolarity. After absorbing water, now medium osmolarity. Okay, it means now water level is high, and solute level is still low, because this here water level is super high, but here water level is only high, not extremely high, because it is absorbed by PCT. Here PCT absorb water. Now this filtrates move further. Here their osmolarity is 400, and now they move further. Now what is the function of Henle's loop? They absorb their descending limbs. This is the descending limbs. They also absorb what? Water. Now it's low osmolarity, means high guys, high osmolarity means water and solute both are equal, because water absorbed by descending limb of Henle's loop. Now here also osmolarity very high osmolarity. If I say high osmolarity means low water and high solute now, and still move further, and there is very less osmolarity, because water, here water is low and solute is high. So solute osmolarity is very high, solute osmolarity very high, and water osmolarity low. Next, this is the balance. And now what happening with loop of Henle in ascending way? Ascending is specific for what? They are impermeable for water, impermeable for water. Now here no water absorb, here no water absorb, only solute absorb, guys. This is the time for solute absorption. Here water absorb, water absorb, water absorb. Here solute absorb, solute absorb, solute. If you take a beaker, you have high water and less solute, then you take same water amount but high solute, and if you remove one by one osmolarity, one by one solid molecule, then again this phase is come. So here solute is removed, solute is removed, solute is removed, solute is removed, then water content is again high. So H2 again high because this is not absorbed. So solute high, solute absorption is high, and then water moves forward. Now this osmolarity and this osmolarity is balanced, and now urine excrete out. I'm writing here, I'm writing here, I'm writing some definitions. What is osmolarity? Osmolarity. Osmolarity means how much solute present in water. How much solute present in water. This is the water content. And there is solute. Then what you say? Then what you say? That water high and solute less means this container have low osmolarity, because water is high and solute is less. Solute is less and water is high, so they have low osmolarity, more pure. If I say this is the container and this container contain low water and high solute, then what you say? That water is very low and solute concentration is very high. So this container contain high osmolarity. Larity means this water is impure because they have high osmolarity, they have more solute compared than water. Let's use some common sense, guys. If water is high, if tubules osmolarity is low, water is high, and water is high, then they absorb by PCT, they absorb by Henle's loop, and they absorb by DCT. If water content is high, absorbed by PCT and Henle's loop, but if water concentration is already low, then how they utilize water? They absorb solute. So DCT part absorb solute, ascending part of Henle's loop they absorb ions. If water is more, then PCT and Henle's loop, descending loops of Henle, they can absorb water. If solute is high, if osmolarity of tubules is high, then DCT part and ascending part of Henle, they can absorb solute. This is the whole mechanism, guys. Use some common sense. Here I remove and I visualize something. Last time I visualize you again that. Look at here osmolarity low or high? Low means water high. Here osmolarity low or high? Compare than this. Here 300, here 400 means water absorbed and solute increase, but water also absorb. Here osmolarity is high, there more highest. Here osmolarity increases if they move forward. Osmolarity high means less water and high solute, and here osmolarity is high, here osmolarity is low, very low, super low, means at here osmolarity, what happened? Balance. Low osmolarity means water high, solute less. Simple, guys, simple. Here and here they balance themselves, and here they're counter current. They show counter current. Up to down they show highest osmolarity, and here high osmolarity is already high, and they show here to here go towards high to low, here low to high, low osmolarity to high osmolarity, and here high osmolarity to low osmolarity. Simple, guys. So that's all for now, and we will discuss about regulation of kidney and some role of other organs in excretion in our next video. So that's all for now. If you like my lecture, if you like my presentations, so you can subscribe my channel. Thank you for listening me, giving me such a time. Keep smiling and keep revising. Thank you.